We're honored to have Dr. Celia Shanaz. Did I pronounce that correct or not?
Perfect.
Okay, thank you. Talking today on the application of deep learning to the fields of biomedicine and healthcare. This is sort of a follow-up to earlier talk that was hosted by the Northern Virginia Washington chapter of the Computer Society that they invited us to join in on the topic of machine learning in general. Dr. Shanaz was introduced to me by a student at VCU who had studied under her previously. And Dr. Shanaz has a very lengthy list of honors and awards that she's won. You've seen that in the meeting invitation. And just very recently, she was elected the 2022 chair-elect for the Women in Engineering Affinity Group. So that means in 2023, she will take over the chair role of that. So we're honored to have her. And Dr. Shanaz, I'll go ahead and let you take over. I'm going to turn off my camera. It looks like most people have done that already, just to conserve bandwidth so that the audio stays as good as possible. Okay, thank you.
Thank you, Alan, for a great invitation and putting it forward for organizing this webinar, for timely dissemination of knowledge. And thanks to my student, Raisa, who is now doing PhD in Virginia Commonwealth University, for connecting me to Alan. And Alan has put so much effort to invite you all. And let me share my screen very quickly. Alan, host has disabled my screen sharing. I need the permission to share my screen, Alan. Alan? Okay.
Okay, I just did it. I had myself muted, so.
Yes, hope you can see it. Hope you can see my screen, right?
Yes, we can.
Okay. Thank you for such a great honor. And, it's an era of knowledge dissemination in the pandemic. I was talking about this, that we were in the middle of the pandemic. It was a curse, but we didn't stop. We started our research, new research in new directions. COVID, and that's the word. So I like to thank the volunteer, our silent heroes, who has made this poster, for inviting us, because I believe in recognizing every single volunteer. And most recently, as said, our launched has been held for the first time in history, because the Global Women in Engineering Committee was launched in 1993. And this is the inaugural WHO election. So it's a great honor. I have been elected for 2022 IEEE Committee Chair-elect, and I will be chairing IEEE Committee in 2023 and 2024. So it's a great honor. If you want to, and it has been announced in IEEE Annual Election website, and also IEEE newsletter has announced it. And it's a great honor. And let me know how I can serve you and how we can collaborate with each other. And this is just a brief bio. It has been already given in your invitation. The most important what I want to tell, that I appeal everyone to be part of at least one technical society chapters in the local community, because IEEE is the largest technical organization in the world. And since I finished my PhD from Concordia University, Montreal, Canada, it was my dream actually that to launch something new, although I started my IEEE journey 20 years back. So I also humbly request you to visit my Google Scholar citation. It's very easy, Celia Shanaj Google Scholar citations, to really not to really understand that uh, how hard work I really needed to do along with my students, because we have a lot of limitations. Limitations of funding, limitations of computational facility, because I work on artificial intelligence, deep learning, and we need first computing machine, and which is not always available for us, you know. And also, since I'm serving as a professor of Department of Tripoli, Bangladesh University of Engineering and Technology, BUET, and that is the highest ranked engineering university in the country, majority of our students are going for a PhD in Canada and United States, as like RISA. So we have scarcity of PhD students also. And also the pandemic started, we sent all our students to the village home because of this pandemic. And still, despite this pandemic, how we really worked hard to really choose emerging topics to continue our research and publish in impactful journals and conferences. And not only that, we found that those were useful to others because people are citing it. And that's a very good, important message for the young generation, that despite all limitations, how you can go forward. And this picture is very important and I'm passionate about it. This is, I believe in power of networking, no matter where I am. And I also believe in innovative ideas in my every state. You know, these are two human chain that I led for Power and Energy Society Day celebration and for IEEE Day celebration by our Women in Engineering Affinity Group. You know, this is a human chain of undergraduate students, graduate students, our executive committee members, industry experts, entrepreneurs, our advisors. Actually, I use that power of networking to get the research funding, to get computational facility, to get the research papers, which is not available. And important to get the connection of the different access of different databases. And in the left side, you can see my involvement in different technical societies, starting from Signal Processing Society, for which I'm the founder in Bangladesh, Robotics and Automation. I'm also a founder, Industrial Application Society, Societal Social Implications and Technology, Engineering and Medicine and Biology, where I'm currently focusing majority of my research, Power and Energy Society, application of deep learning for power signals, Computational Intelligence Society, Computer Society, and many others. And everything I try to connect with women in engineering, because we need to really promote diversity and inclusion, find out the accomplished women and involve them in different technical societies. And right side in the bottom, you can see the United Nations Sustainable Development Goals. Since I live in subcontinent, I always try Indian subcontinent, I always try to connect my research to the one of the United Nations Sustainable Development Goals, like quality education, like sustainable cities and communities, where healthcare is an important terminology in sustainable cities and communities. Since currently I'm chairing IEEE Global Signal Processing, Women in Signal Processing Committee, it is important to invite everyone to our flagship conference, ICAST. and ICIP. In ICAST, we did Women in Signal Processing event where we really could invite Susan Cathyland, who is our current IEEE president, who was president of IEEE Computer Society, and also Leah. Leah is also IEEE past president and also IEEE president of IEEE Signal Processing Society. And also we connected interdisciplinary researchers like Dr. Vandi Verma from NASA for encouraging signal processing researchers in robotics. And most important theme of my research is really know the diversity and inclusion in different technical societies. That's why we have gathered SPS president, future presidents, our VP, our Women in Engineering chair, our Division 10 director, our EMBS hero like Caroline, our IEEE secretary, and also connecting our research to the industry. That's why we have connected IBM, the chief technical penguin of IBM. So the overall effort is really promote diversity and inclusion, to find the good practices happening for diversity and inclusion in terms of research, in terms of reviewers, in terms of conference committee chairs, in terms of speakers, and also connecting our research to the industry. So let me share my research with you. I start with one-dimensional signal, and that's a very significant research, denoising of ECG signal. ECG is, electrocardiogram signals. It's a one-dimensional biosignals. It's very important to reduce the noise because we are connecting with the sensors and the probes, and noise is already there. If we are unable to remove the noise, we will not be able to diagnose the ECG arrhythmia, which are very, very fatal. This is one of my major research and early research, and that has been received citation more than 355. And the outcome, because of this research, my student got admission in North Carolina State University. He has finished his PhD. Now he is doing job in San Diego. Another research is speech estimation is also one-dimensional signal. I'm telling that how I progress towards biomedical signals. The speech estimation from noise environment, it has been published in IEEE Transaction, and it has a very cross-disciplinary research because this algorithm can be used for harmonic estimation for power signals. And also I care about disabled people. And I was thinking there are a lot of people in Bangladesh, and they need hearing aid devices because they are hearing impaired people. So this speech enhancements based on statistical modeling has been published also in IEEE Transactions. And it's a work of 3 generations. Myself, my master's student, and my PhD supervisor. And my student is now finished his PhD from Texas A&M College Station and doing a postdoc in Stanford University. It's a great honor to reshape their life, and the opportunity that I didn't get in my life, they're exercising it. And this research has played a big role behind this. And recently, another one-dimensional signal is biomedical signal is brain electroencephalogram, EEG. This EEG has a lot of applications. One of the important work that I'm doing along with my students is seizure activity classification. And, and also we did this work with statistical modeling, but actually we are now working to apply deep learning on it so that our accuracy is increased and decision-making becomes more accurate and accessible. It has been also published in Biomedical Signal Processing and Control, and she is my PhD student who is doing it. I am also working with different dumb community when we were talking about healthcare and other things. I was interested about sign language alphabet recognition, but when I was Googling, I found a lot of literature in English, but I speak Bengali, And we are the nation that has fought for mother tongue in 1952, 21st February. 21st February is celebrated as International Mother Language Day in many countries over the world. And that's why my students have dedicated their time and talent to develop this sign language database, and working with the Deaf and Dumb Community Association of Bangladesh. And we have applied deep neural network, we call this architecture BGG19, to really accurately detect this alphabet so that in future we can create an interface. And I have a dream that such students by merit will come to the highest ranking university where I'm serving to really order book in the library using this Bengali sign language, order food in the canteen like a normal human being. So I am focusing on my work to ensure education, entertainment, and accessibility to such people where we really need to support them using technology. And this tuberculosis is a huge problem in whole subcontinent since the British era. And doctors are usually looking at the X-ray image and try to do the diagnosis whether this is tuberculosis present or not. But then I thought we should help the doctors with some automation, with some automatic process. That's why we have taken an ensemble of different architectural neural network, Disnet, Resnet, and Inception V3. And we didn't also forget the contribution of machine learning approaches. So we have also taken an ensemble of deep learning, machine learning approaches. Then we have taken a combined decision to have a better detection, tuberculosis detection from the chest radiographs. And recently it has been published in IEEE Access by my students, and also I was working with pneumonia detection and I was applying this deep neural network to detect pneumonia from X-ray images. And when I was working and we are making a progress, and then COVID came. And this COVID came and my students were very discouraged because they were out of internet connectivity. We made a lot of effort to connect them and encourage them to collect data from different sources. These are X-ray images where you can see usually what doctors do. They look at these images and try to tell the report that whether COVID-19 positive or COVID-19 negative. While collecting the different data from different sources, my students became so interested. They started to analyze X-ray images, CT images, and ultrasound images, and they started to compare that which imaging technique is the best one. So I told them, don't compare with the best one, better try to use the multimodal imaging techniques, and they have developed Capsnet, a new architecture. You can Google it, you can find it, and you can find it in my Google Scholar citation. And, they found out this new architecture to really find or detect COVID-19 with a better accuracy using multimodal imaging techniques. And recently in this pandemic, this paper has been published in IEEE Transactions on Artificial Intelligence. I recommend you to visit those papers to really know more about it. And if you are currently doing any work, please let us collaborate so that we don't start from the scratch. The architecture that my students have developed, let us apply to your problem solving, and that will reduce our time and that will enhance the collaboration. And I always encourage our young researchers to really look for new topic. In signal processing society, there is another flagship conference I told ICF. In last ICF, October 2020, there was a new competition launched, and my students were very excited to participate in this competition. The topic was distortion classification in laparoscopic videos, and for this they have designed a Disnet network, and this is very important. This is some examples of laparoscopic video images, and it's important because why? Because there are a lot of errors, surgical error can happen if we want to solve the problem using manual handling. So any surgical error, can cause a fatal death situation. So there is a strong demand to identify what are the distortion present during the surgery and how to make a mitigation plan so that the surgery can be done accurately. So this was our objective of this research, and for this we did signal processing for feature extraction, looking at the videos, and then we have developed a shallow neural network, and we wanted to maximize the accuracy and minimize the loss. This is the overall architecture. We are taking the video frames and taking overlapping images from the video frames. We have developed a feature extraction block and neural network block, and then took the decision. For feature extraction is very important because we have to detect that 4 types of images, like different distortion present there: white Gaussian noise, smoky level, uneven illumination, blur level. These are different features we detect, and this extracted feature array has been sent to Disnet network. This is an example of white Gaussian noise, and these are our equations. You can find it in our paper. We have also published a conference paper based on that after the competition, and you can find details in the papers. And noise variance is a key factor to characterize an image polluted by white Gaussian noise. And also, if you look at this picture, these are smoky. So we have done the histogram analysis. Median of mean values are taken, and smoky frames have less median value. This is a good identification process. And also, if you look at this picture, we can surely see that there is a uneven illumination here, and that's why the ratio of luminance mean to the range is a great indication factor for the change we found. And if you look at this picture, these are like blur images, and there are different reasons for it: camera hardware issue, slow shutter speed, longer focal length, depth of the field. So a blur image will show low variance and less edges. So after we identify such differences, such unique identification feature, then we have sent that extracted feature to the shallow neural network. This is the neural network. My students can tell you better, and it is important to give a self-attention block to really identify which type of distortion present there. And also there are other blocks like LSTM, dense layers, batch normalization, and then to go to the decision. And of course, there are preliminary convolutional layer. And I will tell you why it is a shallow network is required if we go for data set overview. This is very important because it is launched in the competitions. There are 800 videos, and there are total 10 classes. It is not a binary class problem. There are 4 individual classes that we have discussed, and rest 6 are combination of the individual classes. And every class, there are 80 videos. It's not a very big data. That's why we have developed this shallow network. And if you can see the data distribution, we can really understand that there is no data imbalance. I will show you some other research work where data imbalance is a huge problem, and I will tell you what to do. And it is important to have some data preparation, and look at this. It is very important, the outcome, because I'm explaining you in layman terms. Detail can be found in my papers. It is important to present this accuracy in each iteration on each epoch. And at the same time, we need to know how accurate the model is. That's why we have plotted the loss in the left side and in the x-axis for every iteration. For training and validation, we can see the accuracy increases with every iteration. At the same time, the loss decreases. And that's a great thing for our model. That means our model is so accurate. And this is model performance. We have evaluated our model with two parameters. I saw the results, accuracy and loss. And also, it is important to really know how effective your model is for a particular problem. So that's why we have given Cohen-Kappa statistical score. We can see for the training and validation, our accuracy is very high with lower loss, and also Cohen-Kappa statistical score is also very, very high. Then we were exposed to more challenging situation. We wanted to evaluate our performance for the unseen data. Okay, we separated the data set besides the training and validation set, and also we didn't we didn't reduce our accuracy and Cohen-Kappa score much. That means our method, our architecture is robust, and we are quite accurate to really handle the challenging situation. And of course, there should be always comparison. My students are excited about it. We have compared all methods that were uploaded in the competition data set. And if you look at the accuracy, we are in a third rank. But if you look at the average time, we are ranked first, because it is very an important parameter for us, that how fast we can do it. And because it is a surgical error to be determined, so that the mitigation plan can be taken, and we did it very well. And another important work that my group has done is abnormality detection in musculoskeletal radiographs. And you may tell me that why musculoskeletal radiograph? 1.7 billion people around the world are suffering. So I thought that we should do some automatic detection process, so that you can help the doctors in future using some app and make it accessible to all rural community, and they can do it using app. That's why my students have developed a new network that is called Capsule Network. And why Capsule Network? Because we found that there are some limitations of conventional neural network, because it has poor translational invariance, a lack of information about orientation, and it needs huge data set for training. When we are handling biomedical data for healthcare application, it is important to know the data. If it needs huge data set, then seriously it's a problem. So how Capsnet can overcome these problems? Because output from each neuron is replaced by a vector, and max pooling operation is replaced by more effective routing by agreement algorithm. If you look at this is a simple flow diagram of our method. We take input, we do pre-processing, and there are convolutional layer, and finally optimization determines the class capsule to get the output. And we really need some pre-processing, because our data contains images of variable sizes. If you look at this data, 64 cross 64 pixel, 128 cross 128, 2 to 4 cross 2 to 4, just by the visual observation. The 2 to 4 cross 2 to 4 has more prominence, where 64 cross 64 are blurred. We didn't depend on the visual observation only. We have done some subjective evaluation, and in terms of training accuracy and validation accuracy and different image sizes, we can see for 2 to 4 cross 2 to 4, both training accuracy and validation accuracy are much higher. Not only that, we have also evaluated brick score and mix score, two other parameters. Lower the values are better, the features are preserved. And we can see for 2 to 4 cross 2 to 4, the values are really low. And that's why we have a rationale to move with 2 to 4 cross 2 to 4, because it does not lose information even after resizing. This is the proposed structure of the Capsnet. The convolutional one has 256 9 cross 9 convolutional kernel, and convolutional capsule layer has 32 channels and convolutional 8D capsules. And class capsule includes 2 capsules, and each capsule has a dimension of 2. I really request you to visit my papers to know details about it. My students have written it very well, and you can know. I'm just giving our lemon idea that how important it is and why it worked very well. And this is the proposed structure of Capsnet. It's a better understanding about the sizes and how we move forward from the input pre-processed image, and then the convolutional layer, and then the capsule layer, then routing by Ackermann algorithm to take the decision whether it is a normal or abnormal. And for every biomedical data, people will be asking you, what is your data set, from where you have got the data. Our data is a Mura data set with 14,656 images. There are 8,941 images are normal and 5,715 images are abnormal, but still we don't have data imbalance. That's a good way to go. And this is, the effect of routing, why we will take the routing by agreement. Is a process where routing algorithm acts like an orientation popularity filter. Okay, and if you look at this picture, we have plotted training and validation accuracy, training by black, validation by red, and for different types of images in the database, like finger, elbow images like E and F for forearm and shoulder, we can see there is some overfitting happens. To avoid the overfitting, we have rationalized that we take 4 routing, and you will be asked a question, why capsule for this for this network? For that, I showed you before that we have taken kappa static score, and we found that kappa static score is 70.5% for the conventional Densenet using the Mura dataset, whereas this kappa static score is 80.115% for the same Mura dataset, and if you look at this bar graph, the kappa score for all types of image, comparing Capsnet and Densenet, we can see that we provide 10% better accuracy with 50% less training data. That's a huge thing. That's a good thing we could do, that we need less training data. And next to that, how the performance is evaluated by training accuracy and testing accuracy. We have also compared this with state-of-the-art methods, and compared to that state-of-the-art method, if you look at the result of Capsnet using 4 routing in the same data set, you can see that we are providing better training and testing accuracy compared to the conventional method for all types of images in the database. And finally, we need to know how our model is performing, and that's why we have plotted our loss curve by black and red our accuracy curve, and compared with the accuracy blue of Densenet and the purple loss of the Densenet. We can see for every iteration we are performing with better, higher accuracy and for lower loss, whereas the Densenet are providing lower accuracy but higher loss. That's a very important claim for all of us. It's important that how we are performing, and this outcome of my undergrad thesis student, and it has been published also in IEEE Access. You can just read about it and let me know. And I am a strong advocate of women in terms of research, innovation, skill enhancement, and other thing. And I found, due to my visit in different rural communities in Bangladesh. In Bangladesh, I was just the immediate chair of IEEE Bangladesh section, and there are 55 student branches in this section. And I visited on different rural parts of India, Sri Lanka, Malaysia, Indonesia, and also Thailand. I found that our women are suffering from different skin diseases, but they are shy. They don't feel that it needs to be diagnosed. So that's why I thought, let us work with skin cancer. And also our children has a lot of skin diseases. And this is our picture, digital images of the skin. You can find there is a region of interest where they are affected. And we are applying our deep learning architecture to really find that region of interest, and then find what type of skin disease it is. And it's a challenging situation because we are working with 7 classifications, and I started working with HAM 10,000 data set. And if you look at this data distribution, it's a really imbalanced data. For some cases, there are 142 data. In some cases, there are 1,000 data. If a test case comes from vascular lesion, then there is a huge probability of detecting it as a melanoma. So to overcome it, we have applied the data augmentation library in the there are different details you can find in my papers, and the different types of augmentation like zoom, flip left, right, flip top, bottom, rotate, random distribution, skew. And we also apply different fine-tuning strategies depending on the data set. You can also do the same. If your data set is large and similar to the preteen models data set, you can train some layers and leave others frozen. And if your data set is large but different from the preteen models data set, you can train the entire model. We have applied such fine-tuning strategies, and these are the different models: Inception V3, VGG 19, VGG 16, Resnet 50. We didn't lose our chance to investigate all the conventional features for image processing. And this is a typical model architecture for Inception V3. We have used convolutional layer, average full, max full, concatenation, dropout, fully connected, and softmax layers. And this is a top layer stratification. We have used Adam optimizer, and conventional features are pretty interesting. This is a color image. We have used color features, image quality features, and also do histogram analysis with red, green, blue, hue, saturation, YCTCR. And we compared our method in terms of parameter, that's called accuracy. As expected, compared to the conventional features, our models, Inception V3, VGG 19, VGG 16, Resnet 50, has done very well compared to the conventional features. And let me tell you that how Signal Processing Society is offering different competition, SP Cup competition and VIP Cup competition. And from 2020, my team was ranked 4th, and for VIP Cup 2020, my team was ranked 5th. What I want to tell, the ranking is not important. When I first joined SP Cup 2015, my student team was ranked 5th, and they were very upset, and that was removing artifacts from PPG signal or biomedical signals, and this is for important application of healthcare. And I told them, let us publish and work on it. Just don't think it as a competition. And we published 3 journal papers, and as an outcome, one student got admission in University of California, Riverside, and another student got admission in Princeton University. That's Ivy League University Uni. And the recent work is picked up 2020, unsupervised abnormality detection by using intelligent and heterogeneous autonomous system. Now, this COVID era, you can utilize, and I'm thinking of it, that you can apply your deep learning, artificial intelligence to really send medicine to the rural community where you really need it. So it has opened up a new direction of research. And also the VIP Cup topic, real-time vehicle detection and tracking at junction using a fisheye camera. If you want to monitor the hospitals and different offices after this post-COVID era, that work is very important, and we have applied our deep learning techniques to solve this problem. So the problem at hand may have a different application, but you can find different applications related to healthcare or related to your discipline if you really deep dive into it. So let me tell you some of the contributions I made along with my team to really empower our research community. This is IEEE WeCon, Women in Engineering Conference in the area of electrical and computer engineering. For the first time in the world, we launched in Dhaka, Bangladesh in 2015. We had around 90 foreign delegates and around 2 to 3 society presidents were there. That's the first one, and it's a great courage. And then we started the collaboration beyond border. Indian sections between Bangladesh and Pune section, Bangladesh and Uttar Pradesh section, Bangladesh and Thailand section, Bangladesh and Bangalore section, Bangladesh and Bhubaneswar section, because we really want to reach out the underprivileged community where they really need it. Why not? One day we will collaborate with Richmond section to make it a global one, and I will request you to join this 2021 version. I will be sharing the call for paper with Alan. It is already in my LinkedIn page, and you can Google it and become part of this amazing pool of keynote speakers, reviewers, industry experts, students, young professionals, and also in IEEE Women in Engineering International Leadership Summit. Only 10 sections around the world got this opportunity, and Bangladesh was one of them. I served as a general chair, and here, Raisa was hugely involved, and she was involved in designing Women in Engineering project competition, connecting humanity and technology. And we not only talked about leadership, we talked about nuclear power energy education, artificial intelligence, signal processing, so that we can really prepare our women to embrace those technology. Just for your kind information, it was TENSIM 2020, the second largest flagship conference of Region 10, Asia Pacific. And it was Bangladesh has got the bid, win the bid. But everything was stopped. I was served as a general chair, and I thought that no, we must do it for timely dissemination of knowledge, because we received more than 1,000 papers, and we could handle it. IEEE President Toshi Fukuda was the chief guest, and immediately after that, we did International COVID-19 Congress, because our engineering, medicine, biology, our computer society, our industry application society, our signal processing society, we really wanted to gather everyone to know how they're applying their research and how they're continuing their innovation. And I found that, there is a lot of enthusiasm for applying the deep learning, artificial intelligence, robotics to handle this COVID-related problem. Again, Toshio Fukuda was chief guest. And recently in 2021, we did International Women in Engineering COVID-19 Congress, where I found it astonished, was amazed by seeing that how our women, our men, because women in engineering is not just for women. Anyone can be women in engineering member. Research, innovation, and work-life balance during COVID-19, and many of them are using this architecture, deep learning for solving problems related to COVID. It is important to really create a diversified leadership, and we did, connecting with women researchers from Region 9, Argentina, Brazil, industry expert from Brazil, Tunisia, Malaysia, India, and different parts of the world. It is important to do such initiative, to do such panel where the women from Richmond section, women from Bangladesh section will come together, and it will benefit our community. These are some of my awards that I got for my, apart from my best paper awards. It's a Women in Engineering Professional Volunteer Award from Region 10. That's the highest honor in 2013. And also 2015 Women in Engineering Inspiring Member Award from the Global Women in Engineering. Also in 2016 MGL Leadership Award for the contribution in section, region, and globe. And 2019 Region 10 Outstanding Humanitarian Activities Volunteer Award. You know, this is not just a list of awards, this is a list of commitment and hard work, you know. It's just to inspire the young one. And for your information, when I was doing PhD in Montreal, the Montreal W Affinity Group was formed, and I was part of that. The important thing I thought that whenever I go back to serve my country after my PhD, I was a Canadian Commonwealth scholar. I thought that first thing I should do, that I will form a Women in Engineering Affinity Group. And I had the honor to be a founder of Women in Engineering Affinity Group in Bangladesh. And I led forming more than 18 Women in Engineering student branches in Bangladesh. And our professional Women in Engineering Affinity Group became the best one in the whole world. And also, of course, it became the best one in Region 10. Also, the Women in Engineering student branch, for where I'm serving as a faculty advisor, you know, and became also best one in the Region 10, become best one in the whole world. It's an amazing journey. I know a lot of, and many of our volunteers are now finished PhD from Stanford University, University of California, Berkeley, Bader University, Rice is there, and a lot of contributions are made to their life through Women in Engineering activity. And I was first female chair in 25 years history of our section. And I have received this 25 years celebration banner from Region 10 director, and that has enhanced my commitment more. I led my section to win 2018 IEEE Outstanding Large Section Award. It's the highest honor for a section. We did a lot of entrepreneurship activity, industry activity, especially we did a lot of technical activities to progress research in engineering, medicine, biology, where the country needs it. And it is always a great honor to receive the awards for my mentees: Best WI Student Branch, Best Outstanding Region 10 Volunteer, Best Young Professional Affinity Group in Region 10. Our past chair has received the Region 10 Outstanding Professional Volunteer Award. We had to wait 25 years to produce one Region 10 Outstanding Volunteer, but I think we do not need to wait another 25 years. Maybe in 5 years, next 5 years, we can produce another one. And that's a good information. And finally, I want to tell you that why I presented this research and why we're doing the technical group activity and why Alan has united so many organizational units together, because we want to bring visibility of our hardworking researchers, our heroes, our industry expert. And you know what? Our IEEE Engineering Medicine Biology Society chapter has received 2020 IEEE EMBS Regional Outstanding Chapter Award. Only 2 chapters received it. One is in Argentina, one is Bangladesh chapter. You know, I should say that by this hard work, we have increased the visibility of Bangladeshi researchers, I should say the subcontinent researchers, the Region 10 researchers to the rest of the world, and also SPS chapter for which I'm the founder chair and received the chapter certification very quickly, because we have launched our own conferences. In EMBS, we have launched our own conferences. We have organized different distinguished lecture programs, winter school, summer school, to really engage our students. And this year the networking and engagement opportunities are again broad. We have launched 5 conferences, a concept of co-located conference. Seventh time we're going to see PIACON to really engage our power and energy society, industrial application, power electronics, industrial electronics together. RIACON for focus on artificial intelligence, computer science, computer vision, robotics, signal processing, to really invite our signal processing, communication, photonics researcher, and BASICON especially for biomedical engineers, healthcare technology, which are very important in this COVID era. I really request your collaboration. Deadline may be extended up to October 30. I'll be sharing the call with Alan. Alan can share with you, and I'll be very happy if you can partner with these conferences, and so that we can disseminate knowledge beyond the border. So I request you to visit my website, www.celiashanarch.com, to know about me and to let me know that how I can help you, how I can collaborate with you, and how I can contribute to make any change. And this COVID has shown us that how we can work beyond border. And we just need a Zoom link. And it is important to make this virtual world, to utilize this virtual world. And most important thing is that I stayed in Canada for 6 years for my PhD study. And I want to tell the young generation, I never thought I'm from a small country. A person should be evaluated based on the merit, based on the achievement and accomplishment, and the passion he or she can bring to the community. And that's why we always need to think that we are ready, and we need to and I feel ready to take any challenge. And this is for young PhD students who are looking for their industry or academia jobs. No matter what, we can do it, and we can do it. But for this, we need to work together. Collaboration will bring more diversity and more benefit in terms of research and innovation if we can really want to lead this smart world. Thank you, team Alan, led by Alan, once again for inviting me and giving me an opportunity to share my research. I really wanted to share my research, my involvement, my initiatives, and that may bring some benefit to all of you. And also, I'm much eager to know about each one of you, so that I can also benefit myself and bring opportunities for my community. Thank you once again for this wonderful initiative. Take care and stay blessed. If you have any questions, feel free to ask me.
Okay, at this point, if anybody wants to ask any questions, please feel free to unmute yourself and go ahead and ask. Okay, I don't see anybody unmuting at the moment. It is right about the scheduled cutoff time, so we'll go ahead and bring the meeting to a close if nobody has any questions, and I'll go ahead and send the link out to everybody so you can review the recording later. And as I said, I'll also post it back to the meeting site, meeting announcement. And Celia, if you want to send me a list of keywords, then what I can do is modify the meeting announcement so that it includes those keywords. And that way, in the future, if somebody searches the IEEE website to find a talk on a specific topic, and they mention one of the keywords, then your talk will show up.
No
Okay.
problem. No problem. I will share. I will share. Most important, Alan, I need to know about the different expertise of different participants and the organizational units. If you have you have already connected. If you can connect them with me, I can at least send invitation to them. If they feel they want to join those initiatives, they can join there. So
Yep.
Thank you very much.
Yes, what I'll do is I'll send you a copy of the registration list. You know, that's got the contact information for everyone who registered. And I'll also point out the names of the people that I connected with as far as chapter chairs, that kind of thing.
Thank you. That will be great. I will be involving them, copying you because you are the connection point. Thank you for your contribution.
Okay. Thank you. Goodbye,
Thank
everyone.
you. Take care, Alan.
Okay. Bye.
Yeah. See you later. Bye. Take care.